Right, recording has started. You are being recorded. I need to let you know that. So, welcome everyone to our first online lecture. I hope you all got back home safely and all the rest of it. The beacon code is on the screen. I've also put it in the chat so you can copy and paste it in. And I do check beacon. We also keep a register that's a spreadsheet for this and notes going and stuff. So what I do is look at the attendance record kept by Teams, Microsoft Teams, and I think there's someone else needing to be let in. Not sure why. No, that's in the chat. Okie dokie. No, right, that can wait. Um, I'll check that in a moment. So if you find, as I said at the time, that you've logged in on a work ID and it doesn't like it, and you disappear and come back under the university one, I take that into account in the attendance record. Now, remember, you need to attend the whole thing. So whether you're listening to the lecture or working on your assignment, stay in Teams. If you're working on your assignment, you can mute me, but stay in. The thing I didn't mention is things like communication are also looked at. So if I say, are you attending the lecture or the or assignment in the chat, you put a thumbs up against one of those, you've communicated with me. And I can say, great communication. And if you don't, I have to chase you and say, were you listening to the lecture or doing your assignment? And then when we have the monthly meeting, there might be a could improve in communication sort of comment. So those are things that get looked at. I'll cover what we're doing in a moment. After this lecture, I'll make 3 out of the 4 mocks available to you. That's so that you can see the level of question, the sort of thing that you might be asked. Probability trees is tested on the exam. I keep 1 mock back so that until all teaching is finished, so that you can do it as a mock under test conditions if you wish to. Now, I know generally the recommendation is that cameras are switched on for lectures so that we can see engagement, etc. Now, partly we've got the lecture assignment thing going on. Partly there's meant to be 45 of you, and that's an awful lot of cameras to be watching. But mainly, my Surface Pro seems to not like to have too much to think about camera-wise. So I'm definitely going to get you guys to keep yours off. I'll keep mine on for the intro, but when I start sharing my screen and opening files, I will try to remember to turn it off before doing that, because that tends to be the point in the past that it's blue screened. I've had to completely switch it off and log it back on again, and that can take 5 minutes. So if I do disappear, give me 5 minutes or so. I will be back, but I will try to remember to turn it off before doing that. At this stage, before I go into what we're doing today, does anyone want to say anything? Hello?
Nope.
Yeah, microphones tend to be all right. Now I've got two. I'm going to ask you because it's the first lecture. I'm keeping an eye on things a bit more than usual. There's a couple of messages which Selena's requested to join. Come on, but it's saying that there's no requests right now. Let's just check the chat for that. Just checking there's no one. I'm just going to check
Anne, I do have one question real quick.
Oh, hang on, let me just turn my
Sorry.
Oh, yep, so carry on. I can hear you better now. I've turned my thing.
I was going to ask, is it the same meeting for Robin's part of the teaching?
No, that'll be different. Mine just covers my stuff. He deals with this. I'm just going to check whether that person that's wanting to chat with me is one of us, because I don't have all of your names memorized, astonishingly. Let me see. Oh, there we go. Admin. Is he friend or what's his name? He is friend. Okay, so accept. So Dwayne, if you're listening, that's you in. All right, I need to invite him on this account. Okay, so excuse me while I copy the meeting info, copy join info. And so the first time I'm kind of tolerant of this, and then next time it's going to be, no, go away and watch the recording. sometimes you don't know until you get back to where you are what security suddenly jumps in and so on. So we're just going to keep an eye out for Dwayne Madeleine joining in. Oh, which I seem to have done not just to him, but to everyone. Oh no, that's not sorry, that's something else. Idiot me. All right, let's go back to chat. So we've got 32 people in. This is good. And oh, and there's another message. Excuse me all. Right, that was a thank you. So with any luck, we will see Dwayne join us. People. Yep, he's in. He's got Dwayne, you've got a big exclamation mark against you. But you're on the list. So there we are. Good, excellent. Right, so what are we doing today? Today it's going to be the probability that you will have met before but might need a little reminder of, a bit like in Block Week when there are things that said, remember algebra, do you remember there are these things called numbers? Remember there's these, anyway. So a refresher of probability and the basics, that we 0 to 1, fractions, etc. Then it'll be things like the independent events, mutually exclusive events, but then rules, what happens if it's something and something happening, or something happening? How do we write that? How do we deal with that mathematically? That then leads into the meat of it, which is probability trees, which is a way to deal with these complicated situations. There are, if you've searched for probability, there are ways just to write it down, but a probability tree is a sort of a picture way of working out all the different possibilities and how we deal with the number side of that. So at the end, you'll be when I release the files, which I haven't done yet, I will try to remember to release the files just before the lecture. Release the files. In this case, I'll do it after the lecture. I won't stop now and do it, but there are a couple of files for practicing on with the answers there, and we go through building up the probability tree, things like with replacement, without replacement. These are probably things that you're going, oh yeah, I remember doing that. So those of you that are thinking, yep, I definitely need a reminder of that. So I'm now going to the chat. Let's close down participants. How many have we got? 33. Expecting a few more than that actually today, but anyway. So going into the chat, I am going to, so the first one is going to say lecture. There it goes. And the next one is going to go assignment. So everyone needs to put a thumb up against one of those. So if you're thinking, actually, I do need this reminder of probability, stick your thumb up against the lecture. There they go, ticking up. And if you're going, that I did probability trees yesterday, I can do that, that's all fine, then stick your thumb up against assignment. At that point, I have said everything to everyone that I want to. So if you are going to work on your assignment, you can at this stage stay in the lecture. We need 100% attendance for the whole time. At the end, I can close the lecture down for everyone. So if you're, so that will do that. But stay in the lecture so that your attendance record is fine. And if there's any messages that I need to give, I'll stick them up. The thing I didn't say was that recording does not show the whiteboard. So the stuff written on the screen doesn't come up on the recording, which is why I kind of read it all out. Where have we got? So we've got to 24 people who have put a thumbs up. Yes, I think there's a mixture of the Simpsons yellow thumbs up and the more sort of pinky thumbs up. Going up 25. There's 33 of you. I'm expecting 33 thumbs up. At this stage, I'm really encouraging. And remember, the lecture finishes at, although, I mean, with the academic quarter, it would finish at 9:45. I've got until 10 o'clock, and then there's until 10:20 if you've got questions. So I will be around at the end if you need to talk to me. 26 people. Come on, guys, there's 33 of you. 27, so that's 6 people who haven't. I need a thumbs up against one of those, otherwise I have to chase you, or put a comment about your terrible communication when it gets to the review. Because otherwise, what else? Like, right, oh, there's a. I'm just going to check if there's someone else trying to get in. Right, Dwayne, understand. I take it that you can hear me. You can just say yes in that chat that you've got going separately. Okay, and that, oh, sorry, that Dwayne, that thank you. So you've told me, yes, some people don't have access to the chat because of their organization or how they've logged in which case just message me separately and I'll see it there. Dwayne is writing, sorry, can't, so yeah, so if you can't see the chat, just tell me separately. And I will take that into account. Right, so at this stage, yeah, that's fine, good. Right, at this point, I'm going to close my email. Good. Come back into the chat. I'm going to close 20, that's 31 of you. So I've got Dwayne, that's 32. So there's one person out there. And I have taken myself off the number of people who hasn't told me what they're doing. 4, 26, 30, 31, or 2. Anyway, right, okay. I shall find out who they are later. Right, so at this point, I'm going to close down. No, when I get to sharing my screen, I open the files and share my screen, I can't see the chat. So at that point, I'm going to close the chat panel now. I'm going to turn off the whiteboard, if I can remember how. Stop sharing, that'll do it. So you won't be able to see the message on there, but Beacon, and I'm going to share. So at this point, anyone working on the assignment, if you're still with us, you can mute me and go and work on the assignment. And I shall see you next week for the next thrilling installment. But for the rest of you, I shall just share the whole screen. That's going to be easiest. And before I do that, I'm going to turn off my camera, just so I don't confuse my Surface Pro too much. I've also discovered I do need, if I'm going to change from front to back, I need to do that in Teams and not with the camera, otherwise it definitely blue screens. So let's share my screen. And let's go to this one. Right, so what you should, and I am keeping the little panel up, so if there is, I don't think I'll see if there's maximize window note. Right. No, I will minimize that. Right, so I cannot now see Teams. If anyone's got questions, either just turn on your microphone and ask. If you stick it in chat, someone else is going to have to turn on their microphone and ask. Tell me that there is a message, and I can go back and read it and come back. So that's not a problem. Right, ready to begin. Anything anyone wants to say at this point? Say microphones or chat, but if it's in the chat, someone's going to have to let me know. Wonderful.
Sorry, Aaron, I was sorry.
Yeah, carry on.
A bit delayed. So I had a look on Blackboard and these sheets. Are these sheets on here?
They will be. I normally release them just before the morning of the lecture. I forgot to do that today. I will do it in future. I'm just not stopping the lecture to go and do it now, but they will be everything you see on the screen. I will be writing on the screen. That won't be saved, but the file that I'm using to write it from is on there, if you see what I mean. So
Yeah,
the writing is there. So yes, it will be available afterwards, and I've put a reminder to myself to do that. But and then in the future, I'll try to. If you see that I haven't at the beginning of the lecture, if I haven't started, let me know. Remind me, and I'll do it beforehand, because I know some of you like to follow along with it there.
Thanks.
Anything else? Thank you very much. There are real humans there. Right, just having a look to see how many of you I've got with me. Let's just have a look at that. So I've got 27 listening in and 4 doing the assignment. That's really excellent. Wow. It does very much vary week to week, whether how many people are confident with the topic or not, and that's perfectly normal and accepted. And things don't necessarily always get harder as they go along. You know, it's a the individual topics. And some people take to some better than others. Right, so rules of probability. I'm going to scoot through this fairly quickly because you will have met it all before. It's just reminding it and uploading it so that it's all fresh in your mind. So, and I will go back to my rules of probability file rather than the next one. So, probability. How likely is it for something to happen? Where's my drawing pen? There we go, draw. So things, probabilities are measured from 0 to 1. They're all 0 to 1 fractions in between. You cannot have a probability. 1 means something's absolutely definitely going to happen. And you can't have more definite than absolutely definitely going to happen. You can't have probabilities that are bigger than 1. If it's impossible, then the probability is 0. It's 0 chance of it happening. It's not going to happen. You can't have less than that. There are no negative probabilities. And everything else is a fraction. You can so it's between 0 and 1 and can be a fraction or a decimal or a percentage. Hence the little reminder of fractions, decimals, and percentages that we had in block week. Further up the scale to the right, the more likely it is to happen. Less likely, you head to the left. So we would say, and I'm only going to do a couple of these, but the probability that it will rain at least once in March in England, it's not certain. You cannot say it's certain. So it's going to be, the high ones, let's say the 0.99. The probability that a result less than 7, so less than 7 would be 1, 2, 3. Well, sorry, 6-sided dice would be 2, 3, 4, 5, 6, because you can't. There's 0. So that is certain. So that would be the 1, because it's absolutely certain that that will happen. And probability a committee of 5 females will be chosen from a group of 18 men and 4 women. Well, if there's only 4 women, you cannot have 5. So that one would be the 0. It's not going to happen. Okay. So that's just reminding 0 to 1. And it's all fractions. And this is when we start thinking about the ors and the ands, this becomes significant when we thought about, well, is it going to be more likely or less likely to happen? We'll be reminding ourselves that these are all fractions between 0 and 1 when we think about how to remember what the maths is. So estimating probability, and probabilities can be worked out in basically 3 kind of main different ways. There are ones where you can absolutely work it out. If you've got dice and you're throwing them, you can work out exactly every single possibility and the likelihood of each of those happening. Then there's experimental. You don't, if you're not, let's say you've got and I'll be using dice a lot, card dice and things. If you think that's a dice, is it true? Is it a true dice and there actually is an equal chance of everything being chosen, or is it loaded to come up with more 6s and someone's a cheat and a fraud and a fake? And one way to find that out would just be to roll it loads of times. So that's the experiment. So instead of, if it was a true dice, you could work out exactly what outcomes are likely, what outcomes are possible, and out of the number of each of them, which ones are the most likely, and it's the 7 because there's most ways of throwing that. But if you think that someone's frauding, you do the experiment, you throw the dice enough times that you can see either it matches to the pattern of a true dice and is fine, or there's a combination that's coming out more often than others that shouldn't, and the person's trying to cheat. But you would have to roll it a lot of times. If you just rolled it 10 times, that wouldn't be enough. 100 might be beginning to indicate, but really you need to be throwing it loads and loads of times, so that, because chance means that you might end up with several 6s in a row. That's perfectly possible. And you've got to throw it enough times to show that, no, it really is coming up more often than usual. So there's being able to predict it. There's doing it experimentally. And the last one is just to let it run. If you've got a football match coming up, you can't run it loads of times. It's only going to run once. And that's where people are trying to predict the future, which people tend to be really, really, really bad at. People are very good at analysing the past, but really bad at predicting the future. So those are the ways to work out probability. So we tend to be in here dealing with the first situation where things are fair and you are able to work out or you're given the numbers and then you do the maths with that. Either someone's already run the experiment or it's based on experience or whatever. So estimating probabilities. Here we have, probability, let's go back to blue, how often it happens out of how many times in total it happened. So here we've got biscuits, 100 packets of biscuits. It's meant to have a weight of 250 grams. Out of the 100, here are the totals. So 5 of them were 247 grams, a bit low, 3 of them 255 grams, a bit high, and 14 of them were the perfect 250 in the middle. I believe you can see when I'm in, so at the moment my cursor is underneath the 250 gram and I'm taking it to and fro. Could someone pop on and tell me if you can see that?
We can see the line, but not the actual cursor.
Okay, so
I can see the cursor.
So I can see the cursor, but it is a very small
Okay.
pixel. So
tiny dot. It's basically one pixel dot.
Yeah, okay, I can see it. Yeah.
Okay, so it's not very obvious. And let me just see if I can, if I take the thickness up, whether that makes a difference. No, that's not making a difference to the cursor. Right, so I'll try to remember to underline rather than just wave around, because it's not terribly obvious by the sounds of it. Thank you very much, all. You're very responsive. This is excellent, because I know it takes a while to turn your microphone on and off. So if you're looking at the probability that it weighs exactly 250 grams, you take how many, and I would say with probability, work out the bottom number first, because that's where you're thinking, right, what's everything I'm considering here? And especially when we get onto conditional probability, where you may not be considering everything, just a subset. I would say always work out the bottom number first. So a packet, so it just says a packet chosen at random. So at random is telling you that they've all got an equal chance of being picked. I shall do my Are You Smarter Than a 10-Year-Old story in a moment. So bottom number first, a packet. It's not saying an overweight packet or an underweight packet or anything. It's saying a packet. So all of them. We were told that there were 100 packets. So the number on the bottom is 100. We are considering all packets. Out of those 100 packets, how many of those weigh 250 grams? Well, it's the 14. So now, how are we going to leave that? I'm just going to, because it doesn't change the cursor, I'm just saying, taking the thickness of my pen down. Right. So you could leave it as 14 out of 100, and that is absolutely fine. And quite often with probability, because we're about to work out another thing out of 100 and another thing out of 100, it's much easier to compare if they're all out of the same thing. That's why we have percentages, etc. So everything's out of the same thing. So quite often with probability, it is fine to leave it, not cancel down. It's the one situation where, or a situation where it is okay not to cancel down. I would also, and in the test, you'll see in the worked answers that I tend to give the answer in several ways, saying all of these are fine. So 14 out of 100, that would be a tick. You can cancel it down to 7 out of 50. That's in its simplest form. That would also get a tick. You can change it to a decimal, 0.14. That would also get a tick. You could do it as a percentage, 14%. That would also get a tick. Unless you've been told as a decimal, as a percentage, as a fraction, in its simplest form. If you're told how to do it, then do it in that way. If there's something in the question that indicate, if there's let's say there's a probability in the question and it's given as a percentage, then your answer should be as a percentage. Right, let's do the next one, and I'll come back to my thrilling story from television in a moment. Probability that a packet weighs less than 250. Let's change color for this. Let's choose a nice green. So less than does not include the 250. So it's these ones. So less than 250, it's still out of the 100. Oh, that is terrible. So we're still considering all packets. So it's still out of 100. And we've got 5 at 247. We've got 10 at 248. We've got 9 at 250. So that adds up to 24 out of 100. I would also accept cancel down. That's going to be what's that going to be? 6 out of 25. Dividing top by 4, dividing bottom by 4. I would also accept 0.24. I would also accept 24% for that one. And finally, actually, let's keep red for other things. Pick a color. Let's go for this rather fetching pink. Probability, it weighs between 248 and 252 inclusive. In other words, we're including the 248 and the 252 there. And that is going to be 10 plus 9, 19, 23, 33, 41, 51, 57, 67. Yep. So 67 out of 100. Oh, that's a 7. Or 0.67 or 67%. Right. Now, chose the phrase, and in the text I've chosen at random. Probability questions are really difficult to write in a way that they can only be interpreted in the way that you intend. However, the phrase chosen at random is the code for every single packet has an equal chance of being chosen. Now, so I don't know how, if you actually know, I'm not in the chat. There's a program called Are You Smarter Than a 10-Year-Old, which Noel Edmonds presented, and they took children at different ages and had the SATs questions appropriate for that age group back in the days when, I'm not quite sure how much that exists anymore, probably still does. They'll still be used in tests anyway. And they got adults in, and you had the 10-year-old up against the adult, and of course it was kind of like the kid had done this recently, and it was all tipped towards the kids looking really smart and winning, and the adults having a great time. Now, there was a question which I don't think was a SATs question because it was incorrect. Also, as someone else said, that's not at the correct level. However, the scenario was that there were 5 dogs running a race. I can't remember that, but 3 Labradors, and I think the other 2 were corgis or something. And they said, what is the probability of a Labrador winning the race? And the kid wrote down 3 out of 5. I can't remember what the adult wrote down, probably the same thing. And they were told that they were correct. And I was shouting at the screen, no, it's not correct. Because it would only, if there's 3 Labradors and there are 5 dogs, it's only 3 out of 5 if all the dogs have an equal chance of winning. And not only would I suggest that a Labrador would tend to be faster than a Corgi, not an expert, but I believe a Labrador would tend to be faster than a Corgi, but also, and unless it's got a, but also between the Labradors, they're all going to have a different chance of winning because one's going to be faster than another, and the Corgi's going to have to. So they don't have the same chance of winning. So the answer is we don't know, we can't tell unless we've got further information. And that's where, if you did need to know, you'd either have to switch to experimental and get them to run races over and over and over and over and over and over again until you can see, until you get a chance, or have someone who knows about dogs who can predict what's going to happen when you run that one race that's only going to happen once. But the answer is not 3 out of 5 just based on that information. So, and we had this at we went to Wolverhampton races the other day, and there was a race where there were only 4 horses, and some said, oh well, I've got a 1 in 4 chance of winning. I'd say, well, no, because some horses are faster than others. If the handicappers have done their job perfectly, then they've all got an equal chance of winning. If the handicappers have adjusted the weights, all the horses will cross the line at the same time. But in experience, that doesn't happen. So that is my faster than a 10-year-old anecdote. However, so chosen at random is a key phrase. Now then, yes, so let's go to this. So working things out. So knowing that 65% of the population have brown eyes, let's go back to blue. So probability that a person chosen at random will have blue eyes. Well, you could either say 60, well, you don't know what it's out of, so you cannot put it as a fraction. So you could just say 65%, 0.65 as a decimal, or 65%. The Bain point is the next line, which is saying, sample of 2,800 voters, how many of them would you expect to have brown eyes? Well, you know that 0.65 of the population, so you're expecting 2.65 of, and when you hear of, it's usually translated as a multiply. That's how it usually works. So 0.65 of 2,800 is 1,820. So out of that 2,800 sample, you would expect 1,820 to have brown eyes or thereabouts. So that's how that bit works. Now, so far we've known exactly, you've been given the information, you know exactly it was 0.65% of the population, etc. You're given the numbers. Equally likely, yes, there's the point, equally likely. So probability is, and always go for the bottom first, how many things are we considering in total, and how many of those have the thing we're looking for on top? So I'd always say do this one first and then this. Especially when, yeah. So conventional, so you can have, there can be only one thing that happens or several outcomes. So the, let's leave the dice we've kinda, no, very quickly, obtain the number 2. So there are 6 faces on a dice, only one of them has a 2. A number less than 7, well, you can say there are 6 faces of a dice and all of them are under 7, or you can just go straight to it's certain, so it's a 1. A number greater than 6, none of them are, so that would be a 0. And an even number, well, out of the 6 faces, 3 of them have even numbers, which you could write as, or you could say half of them have even numbers, 0.5 and so on. A number less than 4, well, out of the 6 faces, 3 of them have a face less than, an odd number less than 4, sorry, it says. So less than 4, it's going to be a 1 or a 3. So there's 2 of those, which you can cancel down to a third. Okay. Those are the ones we can do straight from, we know the dice, we can go straight and write the numbers down. If we're not sure, we've got to write down all the different possibilities. And if you think of it as counting up in binary to make sure that you've got all of them. So if you think of H heads as 0 and tails as 1, so H, 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 T, H, H, T, T. I'm going to come over here. T, H, H, T, H, T, 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 H, and then all the tails. And that's one way of writing down, if you've got a coin tossed 3 times, remembering that there's when you hit with coins and probability, unless they say otherwise, take it that it's either heads or tails. It is it's not quite, because it is possible for a coin to land on its side. And it's saying, it hasn't said, we are assuming this is a true coin. These are all the possible outcomes. And in working this out, we are going to assume that this is a true coin and not one that's weighted. So there are 8 different possible ways that it can land. So probability of obtaining 3 heads. Well, how many? Remember the bottom number first. How many different ways in total? There are 8 ways in total. 3 heads. There's only one way that can happen. Whereas 2 heads and a tail, well, it's still out of 8. There are still 8 ways of it happening. There's 2 heads and a tail. Come on, there we go. There's 2 heads and a tail, and there's 2 heads and a tail, and no, I've done it the wrong way around. I've done 2 tails. Thank you very much for not pointing that out and letting me recognize them. There we go. I was looking for 2 tails and a head. I don't want that. I want 2 heads and a tail. So there's 2 heads and a tail. There's 2 heads and a tail. And there's 2 heads and a tail. That's correct, isn't it? Yes. So there's 3 of those, and we'll leave. And especially here, I'm thinking I could change it to a decimal, but actually 3/8 is easier once you get into eighths. Halves and so on, it's a bit more easy. Sometimes there's a certain degree of choice as to how you leave it in here. So rules of probability. So that's how we're working that out. Write out all the possibilities, and that's in a way what probability trees are helping you do. They're helping you to write out all the different possibilities of how it could land. Right, rules. Composite events, 2 or more events. So something happens and then something else happens. And the question is, are they related or not? Does what happens in the first one affect what happens in the second one? If it doesn't, like if you're flipping a coin and you're rolling a dice, the flip of the coin does not affect the roll of the dice. Those are independent. They're independent of each other. But sometimes something does, and this is where with probability you instantly forget all possible scenarios in which case it happened. But sometimes one thing happening makes it more or less likely that something else is going to happen. Weather, when in a high, if it's sunny on one day, that makes it more likely it's going to be sunny the next day. It sort of sets in and it gets more and more likely that it's going to be sunny. So that wouldn't be independent, because what happens first affects what happens second. If it doesn't affect it, like the coin and the dice, then it's said to be independent. Kind of unrelated, but we also need to look at mutually exclusive. So mutually exclusive means they cannot both happen at the same time. The probability of you being in 2 places at the same time is that you cannot be in 2 places at the same time. That's when the Venn diagram does not overlap. So probability of obtaining a 1 or a 2 when an unbiased dice is rolled, that's excuse me, that's mutually I'm not going into all the different things. I'm just saying which of these is it. So that would, we're introducing the or and we're introducing the ands here. So that would be mutually exclusive, because you cannot get both a 1 and a 2. It's one or the other. A coin tossed and a card drawn, well, those are those are independent of each other. The coin, whatever you get on the coin and whatever you get on the card, doesn't affect each other, so those would be independent. Okay, moving on. So I do need to get, where are we? We are definitely going to be going up to 10 o'clock, I think. So addition rules. So probability. Now think of this when you're working. So if you're saying A or, so this is written as the probability that it's A or B. Probability of A, probability of B. What goes in the middle? Compared with probability of A and B, you've still got the probability of A, you've still got the probability of B. What goes between them? Think about winning the lottery and getting struck by lightning. Both of those really unlikely. And this is where we go back to, remember, probabilities are in fractions between 0 and 1. If you multiply fractions, then you get a smaller number. Half of something is smaller than the something. So it's getting less likely. A smaller fraction means it's less likely. If you add fractions, you get a bigger number. A third plus a third is 2/3. It's bigger. It's more likely. So if you add, it gets more likely. Bigger, more likely. And if you multiply, it gets smaller, which means less likely. And the chances of winning the lottery or being struck by lightning are small, but it's bigger than each on their own. One, because either of them could, yeah. So whereas if you're saying what's the probability of winning the lottery and being struck by lightning, that's going to be vanishingly small, so it's smaller than either of them on their own. So when it's or, we're going to add because it's more likely. When it's and, we're multiplying, it's less likely. We don't meet these you don't have to worry about these in probability trees, but for completeness, it's telling you what happens if they're not independent. So that's if they're independent. If they're not independent, then we need to modify that, and this is the modification, but I'm not going to go into that now because we don't need it for the probability. Now, this one we do want. Probably the event does not occur. Remember, on our probability line, we go from 0 to 1. If this is the probability that something happens, then this is the probability that it does not happen. Now, either happens or it doesn't. So the probability that something happens is 1 take away the event that it doesn't happen, and likewise the event that it doesn't happen is 1 take away the event that it happens. Happening and not happening have to add up to 1, because it either does or it doesn't. That's a certainty. So if the probability of passing your driving test is 3 out of 11, the probability of failing the test is 11 take away 3 out of 11, so that's going to be 8 out of 11. Or you could write it as 1 take away 3 out of 11, 8 out of 11. And quite often in the test, I'll get you to work out a probability of something happening and then say, what's the chance of it not happening? You cannot add up all the probabilities, but you don't have to. You can just take it away from one. Right, I am going to, no, we're just, so probability that it finishes on time, so 2 jobs, probability that it finishes on time is 0.3. The second job finishing on time on 0.4. So the probability of both finished on time. So the first one, probably 0.3, the second time was 0.4, that they both finish on time. So it's the first and the second. It's going to be smaller, so we multiply 0.12. The probability that neither of them is finished on time is going to be the difference. The first one, so if it's 0.3 that the first one finishes, it's 0.7 that it doesn't. And the second one's going to be 0.6, 0.42. And we're going to leave that there. Okay, it's in there. So at this stage, any questions?
No.
Okay, marvelous. I don't think so. Right, so probability trees. How do we express that? When you've got lots of things going on, there are ways to write it down kind of like sentences mathematically, but probability trees is a picture way of doing this. Now, trees start at a single point. So they do like that. That is correct. Doing that is not. You put the probabilities on the branches along. Then it's going to be right. I'll let you read that at the same time. So and I'll talk to you. You've got that as notes. So let's do a first one. Right. Chances of sunshine in May is 60%. So the chance of a cloudy day is 47%. On 2 consecutive days, work it out. Now we're going to say that these are independent, which I would, that whether it's cloudy on the first day or sunny on the first day does not affect what happens on the second day. So here is our starting point. We've got, is it going to be sunny or cloudy? Now, I'm quite happy for you to go S and C. If it's in the question and clear, I'll take it. Otherwise, I'd rather have sunny, a little key saying cloudy, sunny and cloudy. So 60%, I'm going to stick them in as fraction, as decimal 0.6, 0.4. That's day 1. So events in order. The first event is day 1 weather. Second event is day 2 weather. It can be sunny and cloudy, sunny and cloudy. The percentage, the Probabilities are the same, 0.6, 0.4, 0.6, 0.4. And seeing that at each stage these add up to 1, 0.6 plus 0.4 adds up to 1. We've covered all eventualities. So if it's sunny and it's sunny, now this is where it's the and comes in, and we multiply. 0.6 times 0.6 is 0.36. Sunny and cloudy, 0.6 times 0.4, 0.24. Cloudy, then sunny, 0.4 times 0.6, another 0.24. And cloudy, then cloudy, 0.4 times 0.4, 0.16. Now these should add up to 1. So those add up to 0.4, those add up to 0.6. So yes, they do add up to 1. If they add up to 1, we have considered all eventualities. If they don't, something is wrong somewhere. And you can then just use this to pick answers out. So 1 sunshine and 1 cloudy. So we've either got sun and cloud, so we want this one, or cloud, then sun, so we want this one. It's going to be 0.24 plus, so remember now, or sunshine, so one sunshine, 1 cloudy, so 0.24 or 0.24 is 0.48. Probability of 2 cloudy days, cloud, cloud, it's this one, 0.16. Now, at least one sunshiny day means it's not cloud and cloud. Oops. So you can either say that it's, I'm going to change colour. No, let's go back to blue. No, I don't want to go to blue. Let's do this one. So you can either say it's not cloud and cloud, or you can say it's these. So you can either say the hard way, 0.36 plus 0.24 plus 0.24 is 0.84. And I'm going to put that in brackets. Or you can say it's not cloudy and cloudy, so it's 1 take away the answer that we had before, 0.16. Where that came from there is 0.84. And when you've worked out just one thing, everything else plus that has to add up to 1. So if you spot that it's a not something I've worked out, it's very straightforward. And sometimes the number of marks attached indicates that. Am I asking you to add up 24 numbers, or am I asking you to do one sum for 2 points? I wouldn't do a massive probability tree because they're quite time consuming to draw. At this stage, are there any questions? Does anyone not see where any of those numbers came from?
No. All good.
Okay, great. Thank you.
All
Nothing
good,
in the
thank
chat then. So in the test, there are marks allocated to drawing the tree and then marks allocated to answering things from it. Right, there's one more thing. So there, so we're assuming that those are independent. Now, I'm going to start doing this first one, but then move on to the second one to make a point. So there are our beloved box of 15 counters, 2 counters sector around. They haven't said, but because it's a probability question, we're going to assume that all counters have an equal chance of being picked. If you're going in, you can't see them. They're all the same size, shape, and weight. You know, it's not like going in and reaching for money where you can tell by feel which is the pound coin and which is the penny. So we've got 15 counters. 2 counters are selected at random from the box. So what? And this is where, so we take a counter out, we replace it, and we take another one out. So we've got red ones, we've got green ones, and we've got blue ones. This is the first counter. And this is the second. So we pull one out, we put it back in, That's the second counter. So each time we've got red, green and blue, red, green and blue, red, green and blue. 15 counters, so out of 15 we've got 3 that are red, we've got 7 that are green, we've got 5 that are blue. We take it out, we put it back in. So we've still got 3 red out of 15, we've still got 7 green out of 15, and we've still got 5 blue out of 15. And it's the same down here, 3 out of 15, 7 out of 15, 5 out of 15, and then the same at the bottom, because we've put it back. Now, we have to deal with a situation where it isn't replaced. I'm just going to make that a little smaller. Now, so now it's not replaced. So we set it up, first of all, in the same way. So we still have first counter and second counter. And the first time we pull it out, and we've still got R, G, B, R, G, B, R, G, B, R, G, B. And because the question had red, green and blue, it's pretty clear RGB is red. Otherwise, it would be good to put a little key on the side. Interest of time, not going to do that. So first time you pull it out, it's the same. 3 out of 15, 7 out of 15, 5 out of 15. But we haven't put the counter back. So there's now only 14 counters in the bag. So as I said, always consider what it's out of first, and these are all now out of 14. Not only that, and I'm just going to make that a bit bigger, so now. Not only that, but there's, depending on what we picked out first, depends on how many of those there are in the bag now. So if the first time we picked out a red, there are still 7 greens and 5 blues, but that we've picked out a red. So instead of being 3 reds, there are now only 2 reds in the bag. If we picked out a green one, there are still 3 reds and 5 blues, but instead of 7 greens, we've now only got 6 greens. And if we picked out a blue, there are still 3 reds and 7 greens, but instead of 5 blues, we've now only got 4 blues. So when we come to work out our probabilities, so if we pick out a red and a red, it's 3 out of 15 times 2 out of 14. If we're picking out a red and a green, it's still 3 out of 15. Still got 7 greens, but it's out of 14 for the next one. And if we're picking out a red and a blue, 3 out of 15 times 5 out of 14, and the same for all the others. So you've got to be mindful of what is left. And when you've worked all those out, all of these, check, do they add up to 1? Because if so, it's an indication that you're doing all right. Right, it is 5-2. That is what you need to know about probability trees. I am going to go back to the team at this point and see messages that I didn't see before. Can't currently see slides. Great, so Graham's sorted himself. Well done. Let's say the recording will be there. So I shall turn my camera back on. Hope to not blue screen. Any questions about probability that I've just shown you there, or anything generally?
No, not from me.
Brilliant.
No,
Okay,
not for me.
so
We've got one hand.
Oh, we do have a hand. Who's got their hand up? That is
Me, hi.
Maya.
I was gonna ask, is what we've learned about probability applicable to assignment item 3 with the conditional probability, or is that a later lecture?
Conditional probability next week.
Okay, cool.
I've already hinted about some of the things that are coming. There's a couple of questions you'd be able to do, but there's a couple that we haven't covered that yet. So
Yeah, okay.
yes, the assignment is conditional probability next week. Probability trees is on the exam.
Cool, thank you.
Right, I shall hang around until everyone's disappeared or I've worked out that they're not actually listening in. So it was a pleasure seeing you all. Well, not seeing you all, it was a pleasure having you all there. Hope that will, I'm just going to put down at the bottom for speed. And it's just interesting, speed. So was the speed of the lecture fine? Speed too fast? Speed a bit slow? And it's just interesting to see how you found. As I say, I try to capture everyone because this is the whole point of this, is bringing everyone up so that they know what they need to do. But it's just interesting to know. Oh, good grief! This is wonderful. Good. Excellent. So you can now drop off if you like. See you next week. I will hang around. So if you've got questions for me, but I shall now both stop sharing and I shall stop recording. So if there's anything that you want to ask, that won't be recorded because I think we've covered all the probability stuff. So stopping recording now.